How do you identify snow crystals in a snow pit? Have you ever wondered how scientists study snow in the polar regions? Identifying snow crystals in a snow pit is a fascinating process that reveals much about the snowpack. Let's break down how researchers do this step by step. First, researchers start by digging a vertical trench or pit in the snowpack. This action exposes the different layers of snow, known as stratigraphy. Each layer represents snow deposited during specific weather events or altered by environmental conditions. Next, they visually inspect these snow layers. By looking closely, they can distinguish between different layers. Each layer tells a story about past snowfall and how it has changed over time due to factors like temperature and wind. To get a closer look at individual snow crystals, researchers use magnifying tools such as a magnifying glass or a hand lens. These tools help them classify the crystal types based on their size and shape. For example, they can identify fragmented crystals, which are broken pieces of larger crystals, and multifaceted crystals, which have many flat faces and form under stable temperature conditions. Another type of crystal they might find is depth Hoar crystals. These are large and cup-shaped, forming when there are strong temperature differences between the warmer snow below and the colder air above. Typically, these crystals are found near the ground or ice interface. To measure the physical properties of the snow, researchers use instruments like the snow micropen. This tool is a penetrometer equipped with a force sensor that penetrates the snow at a constant speed. It records changes in resistance as it goes deeper, helping to identify layer boundaries and the presence of ice lenses or compacted snow. This information supports crystal identification by revealing structural differences in the snowpack. Classification of snow crystals is done using established schemes based on their shapes. Researchers look at descriptors like dendricity, which refers to the complexity of the outline, and sphericity, which indicates how round the crystals are. These descriptors help differentiate between rounded grains formed by wind compaction and faceted grains formed by temperature changes. Identifying snow crystals in a snow pit is not just an academic exercise. This process is essential for understanding snowpack stability and energy balance in polar environments. The knowledge gained is vital for climate studies, avalanche forecasting, and interpreting satellite data of snow-covered regions. In summary, identifying snow crystals involves digging a snow pit, visually inspecting layers, using magnification tools, measuring properties with instruments like the snow micropen, and applying classification criteria. This method provides essential information about snow structure and its evolution in polar regions.